All right, we're picking up in Chapter 4, Section 1. We've been talking about modeling with linear functions. And what that has entailed is taking real-world situations and data, using that data to create a slope, using that slope to create the equation of a line using one of the points, so that we can find out any place on that line by plugging in an x and getting a y. Now, in real life, data does not always show an exact linear relationship. When the data in a scatter plot shows an approximately linear relationship, you can model the data with a line of fit. A scatter plot is you take a bunch of data points and you plug all those points in on a graph, and they're going to be in sort of random places. Now, if that random places does kind of look like a line, you can actually draw a line as close to all of those places as possible, going through the middle of them, and that is a line of fit. And you can calculate what the equation is for that line, and that will get you an approximation of the data that you have gathered. Okay, so let's try that. Here we're talking about femur lengths in centimeters and heights of people in centimeters. Does the data show a linear relationship? Well, if we take the chart over here and we plug it into a graph, we get a graph that looks somewhat like this one over here. And if you look at the little blue dots, okay, and I'll blow that up real quick. If you look at the little blue dots, they don't follow a real tight line pattern, but we can put a line of fit through there, okay? And that line of fit, we can find 2 points of data on there that we can use to find a slope, and we can create a line for this. So it does show a linear relationship. And so if so, get my red pen out here, we're going to write an equation of the line, and we're going to use it to estimate the height of a person whose femur is 35 centimeters long. So let's find the slope first. Y is on top, x on bottom. So 195 and 50 is 1 point. 170 and 40 is another. You can flip those left and right. You just can't flip them top and bottom. Okay. And you can't flip one set without the other. Notice the 50 goes with the 195. The 40 goes with the 170. Okay. So let's do the math. 195 minus 170 equals 25. 50 minus 40 is 10. Reduce that by factors of 5. You get 5 over 2, or 2.5, 2.5. Either one is good to use. I like rise over run, so 5 halves is good. But most of your calculator decimal people, so 2.5 also okay. So then we set up the point slope. Y minus something equals the slope times x minus something. Plug in the slope, 2.5. Plug in a coordinate. I'm going to use the 170, the 40, 170. 40 goes in by my x, 170, okay. Notice we're not using the data from the actual chart. We're just using the points on the line that fits, not the data out of the chart. I've only got 2 options. Excuse me. Distribute. Y minus 170 equals 2.5x minus 100. Add 170. Y equals 2.5 x plus 70. We've written the equation. 0.5 kind of sucks. There we go. There's our equation. Part 1 done. Now we got to estimate the person whose femur is 35 centimeters long. Well, femur length is an x thing, so we're going to plug that in for x. Y equals 2.5 times 35 plus 70. So y equals 87.5 plus 70. Y equals 157.5 centimeters. They would be 157.5 centimeters tall. Okay. Now, it is the case that we did it pretty well. We drew a line, we saw some points, and so we put a line on there and we did the best we could. But that's not the best. Technology is going to be able to get that a lot closer and a lot more calculated, and it will be able to find what is called a line of best fit, which is the line that lies as close to possible to all of the data points. So a technology tool like your calculator, the big yellow, can do what's called a linear regression that you can use to find the line of best fit. Now with that comes the correlation coefficient denoted by an R. So it tells you how well the data correlates to the line. It goes from -1 to +1. The closer it is to either end, the -1 or the +1, the more accurate the line is. The closer to 0, the less accurate. Basically, no points lie on the line. Okay. It goes to -1 when it has a negative slope. It goes to +1 when it has a positive slope. So if it's decreasing, it'll be close to -1. If it's increasing, it's close to +1. Now let's look at how to type that in the calculator. Okay. So we're using the same data that we had on the last question. It's about the femur and the height of the person. Okay. We're going to use the linear regression feature on a graphing calculator to find an equation of the line of best fit. Okay, and then we're going to estimate the height of a person whose femur is 35 centimeters long. Compare this to the height estimate you got. Okay, so what we're going to do is you're going to go onto your graphing calculator and you're going to push stat. Okay. You're going to push stat. Enter the data. You're going to push stat. The first thing that comes up is an edit, and then next to that is calc. Okay, in the edit column, you're actually going to push edit. And you're going to change the data in list 1 and list 2. List 1 is going to be all your x's. List 2 is going to be all your y's. It should end up looking like this right here. Once you get all of that entered, you're going to push stat again. Okay, and I'll put it back on here. Edit. Enter x in L1. Enter y in L2. Then you're going to push stat again. Then you're going to push right to calc. Oop, should be AL. Then you're going to go down to number 4, Lin, and it should say reg. And you're going to push enter. You're going to make sure that it uses your list. Make sure it uses list 1 and 2 or whatever list you put it in. Then calculate. Once you calculate, you will get a list that looks like this. You may not see the r squared and the r, but you should have y equals ax plus b. Your a, 2.6035, blah, 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 blah. We're going to round to the nearest hundredths or tenths, depending upon what they ask for. Your b, we're going to round 64.99 rounds up to 65. So we're pretty close. We used to have y equals 2.5x plus 70, and they want 2.6x plus 75. Okay. So you can graph the regression equation with the scatter plot, and then you can use the trace feature on the graph to find the